So now let's look at this concept of atomic mass. Atomic mass is the number that is found directly below your chemical symbol on the periodic table. So for example, with chlorine, we have an atomic mass of 35.45 AMU. And the atomic mass is the average mass of atoms that compose each element. It's different than mass number. Remember, mass number is the number of protons plus the number of neutrons. But each atom that we have, or each element that we have, is made up of different isotopes. And one isotope can be slightly heavier than the other, or slightly more abundant than the other. So our atomic mass takes into account the different isotopes of each element, and we take the average of that and report it as atomic mass. So how do we figure out atomic mass? Well, we use this general formula of the fraction of isotope 1 times the mass of isotope 1 plus the fraction of isotope 2 times the mass of isotope 2, and you would continue to do that no matter how many isotopes you had. So if you had 10 isotopes, you would take the isotope of 1 times the mass of 1, and then you would add it progressively to each isotope multiplied by its fraction. So this is analogous to the concept of calculating your grade in the class. If you have, let's say, 3 tests, and your first test is worth 25%, your test 2 was also 25%, and your final was 50% of your grade. And let's say that you got a 79 on the first one and 85 on the second one, and then you ended up with an 87 on the final. That was your score. How would you figure it out? How would you figure out your grade in the class? You would take your test 1, and you would take the fraction of the isotope, and this is convert into decimal value. So you wouldn't say 25% times 79, you'd say 0.25. And of course, by moving the decimal place 2 times to the left or dividing by 100, times your 79 plus your test 2 result multiplied by its fraction. So the fraction is 0.25 again, multiplied by 85. And then your test 3 result, which is this time worth 0.5 or 50% of your grade, or converted into fraction form, 0.50 times 87. And the sum will give you the sum of these components will give you an average for your grade. So let's do an example using a real element with its isotopes. So gallium has 2 naturally occurring isotopes, gallium-69 with a mass of 68.9256 AMU and a natural abundance of 60.11%. And gallium-71 with a mass of 70.9247 AMU and a natural abundance of 39.89. Calculate the atomic mass of gallium. Okay, so we saw that gallium-69 has a mass of 68.9256 and abundance of 60.11%. So 60.11% of any given sample of gallium is going to be our gallium-69. Okay, and our gallium-71 there is got a mass of 70.9247 AMU, and its abundance is 39.89%, so it's a little bit less abundant. So our atomic mass is going to be the fraction of our isotope 1 times the mass of isotope 1 plus the fraction of isotope 2 times the mass of isotope 2. So we will convert the 60.11% into fraction form. So it becomes 0.6011 times our mass. And then we will convert this into fraction form as well, times our mass of our isotope 2. And that's it. We only have 2 isotopes, so we will plug this into our calculator. We'll end up with 69.7231 AMU, but we are limited by 4 significant figures, so we will report this as 69.72 AMU. Okay, go ahead and give this a try. Now, magnesium, on the other hand, has 3 naturally occurring isotopes with a mass of 23.99, 24.99, and 25.98 AMU, and natural abundances of 78.99, 10%, and 11.01% respectively. So let's calculate the mass of magnesium. So we saw that for our isotope 1 is 23.99 AMU, and the abundance is 78.99%. For isotope 2, we have a mass of 24.99 and an abundance of 10.00%. And isotope 3's got a mass of 25.98 and 11.0%. Okay, so let us figure out our atomic mass is going to be the fraction here of isotope 1, which is 0.7899, times our mass of isotope 1 plus our fraction of isotope 2 times our mass of isotope 2 plus our fraction of isotope 3 times our mass of isotope 3. Okay, and we plug this in, and we end up with 24.308, and we are limited by 4 significant figures, so we will report it as 24.31 AMU. Now, we look at it and just kind of make sure that we got the right answer, that we did the math correctly. It should be an average of these 3 masses that were given. And which of these isotopes is going to have the most impact on our number? It's going to be the isotope, of course, that's more abundant, which is isotope 1. So we see that our average is going to be actually closer to 24 than it is going to be to 25 or to 26, because we have about 79% abundance for isotope 1. It's kind of like if your final is going to be worth more than your test, so it's going to affect your grade more than your individual tests. So you would have to get a better grade on your final to raise your grade in the class.